Welcome to another revision video for the Edexcel Core 3 Maths A-Level syllabus. In this video we will do past paper questions on trigonometry, but in particular solving fairly simple equations and identities involving trig. Not identities or equations involving additional double angle formulae, more straightforward ones than that. As always, for each question pause the video, attempt and then mark your work against my solutions. Let's start. Okay, part A. It says, use the identity cos squared plus sine squared is 1 to prove that tan squared is sec squared, subtract 1. So, these are always the same. Hopefully you have learnt these. They're very straightforward indeed. So cos squared plus sine squared is equal to 1. If we divide everything through by cos squared, divide everything you see by cos squared theta. Squared theta divided by cos squared theta plus sine squared theta divided by cos squared theta equals 1 over cos squared theta. Now cos squared divided by cos squared is 1, sine squared divided by cos squared is tan squared theta, and 1 divided by cos squared is sec squared theta, and therefore tan squared theta, subtracting 1 off both sides, is sec squared theta, take away 1. As required for 2 easy marks. Part B, solve for theta between 0 and 360 the following equation. Now, you've got to think to yourself, oh, why did I do part A? Part A told me that tan squared is sec squared take away 1. So from part A, I know that tan squared theta is sec squared theta, subtract 1. Now this equation here has tan squareds, secs and sec squareds. In order to be able to solve it, it would be best if everything was in terms of sec squared and sec theta. So we can substitute for tan squared theta in here with what we did in part A. So we can say, substituting for tan squared theta, that 2 sec squared theta subtract 1 plus 4 sec theta plus sec squared theta is equal to 2. Expanding out, 2 sec squared theta subtract 2 plus 4 sec theta plus sec squared theta. I'm also going to take 2 off both sides, subtract the 2 is 0. And now I can combine. I have got myself 2 sec squared theta plus another sec squared theta, i.e. 3 sec squared theta. I have got myself plus 4 sec theta here. So plus 4 sec theta, and a negative 2 and a negative 2 is a negative 4, is 0. This is a quadratic which I can factorise. 3 sec theta, and what would it be? Well, it would be plus 2 and subtract 2. So therefore sec theta from this is 2/3, or sec theta is negative 2. Therefore, as sec is 1 over cos theta from this would be 3 over 2, which you ignore. There's no solutions because cos is between 1 and -1. And from this, cos theta is negative 1/2, which you can solve. Theta is the inverse cos of negative 1/2, making sure you keep your calculator this time in degrees mode. So you do in your calculator inverse cos of negative 1/2, and you get yourself 120 degrees. So let's just extend that. Theta is 120 degrees. We're looking for solutions between 0 and 360. So draw out your cos graph here. The cos graph looks as follows. That point there is 90. That point there is 270, and 360 is over here. Now you know there is a solution at 120, which is about here, which is 30 degrees from 90. So there'll be a solution 30 degrees back from 90 at 240. So the other solution is theta is 240 degrees, and we're done. Maybe you'd want to sub back in the exam and check it. When you do, you get 2, but that's the answer. Pause the video, have a go. Okay, working through, again we're asked to show an identity. We know that sine squared theta plus cos squared theta is equal to 1 or identical to 1, and we want to show this. So what we can do is we can divide everything we see by sine squared theta. So I would get sine squared theta over sine squared theta plus cos squared theta over sine squared theta is identical to 1 over sine squared theta, and sine squared divided by sine squared is 1, cos squared divided by sine squared is cot squared theta, and 1 over sine squared is cosec squared theta. Easy 2 marks. Next part, we're asked to solve an equation for theta between 0 and 180 degrees, and here it is. We're asked to give our answer to 1 decimal place. Now, the equation has cot squareds and cosecs in it. In order to be able to solve it, everything should be in the same term. Now, you know from the previous part that 1 plus cot squared is cosec squared, and in particular, you know therefore that cot squared theta is equal to cosec squared theta subtract 1 from part A. So substituting in place of cot squared theta, we could say 2 cosec squared theta subtract 1 minus 9 cosec theta must equal 3. Expanding out, we get 2 cosec squared theta subtract 2, subtract 9 cosec theta, and then subtract this 3 from both sides is 0. And tidying up, we get 2 cosec squared theta subtract 9 cosec theta subtract 5 is equal to 0. Just change that to 5 here. Can we factorise this? Well, yes we can. This factorises fairly easily into 2 cosec theta subtract 5 and plus 1 is 0. So therefore we get that cosec theta is negative 1/2, and cosec is 1 over sine, so therefore sine is the inverse of this, must be negative 2, which you can ignore because sine is always between 1 and minus 1. And this one tells me that cosec theta is 5, so therefore sine theta is 1/5, which I can get solutions for and I can work out easily. So theta must be the inverse sine of 1/5. So type that into your calculator, keeping your calculator in degrees mode, and we get ourselves 11.5 degrees to 1 decimal place. You draw yourself a quick sketch of the sine graph just to check you've got all your solutions in between 0 and 180. You know the sine graph looks as follows. That's 180. If you've got a solution at 11.5, you will have one that is 11.5 back from 180. So your two solutions therefore are theta is 11.5 degrees and 180 subtract 11.5, which will be equal to 168.5 degrees, and they are your two solutions. You're done. Okay, next question. Pause the video, have a go. Okay, part A. It's the same old trick here. We've done these before now. We've got that sine squared theta plus cos squared theta is identical to 1. And we want to show the following. If we divide everything through by sine squared theta, we would get sine squared theta over sine squared theta plus cos squared theta over sine squared theta is identical to 1 over sine squared theta. So this is 1 plus cot squared theta is equal to cosec squared theta, and therefore 1 subtracting cot squared of both sides is identical to cosec squared theta subtract cot squared theta. And we've done 2 easy marks. Okay, part B says hence or otherwise prove the following. Prove that cosec to the power of 4 theta subtract cot to the power of 4 theta is equal to this. Well, hopefully you might notice this is the difference of two squares. It is as follows. You could write, let's start off with the left-hand side. You could write the left-hand side, i.e. cosec 4 theta subtract cot 4 theta. You could write it as cosec squared theta plus cot squared theta multiplied by cosec squared theta subtract cot squared theta. Now in part A, you realise that cosec squared theta subtract cot squared theta is actually 1. So this is therefore equal to cosec squared theta plus cot squared theta times 1 by part A, which is what you're looking for, which is a nice quick way of getting cosec squared theta plus cot squared theta. And you've got what you're after for 2 marks. And that is equal to the right hand side, and you're done. And part C, it says hence solve this equation. Or it doesn't even say hence, it says solve between 0 and 180 this equation. Well, obviously you are, in order to solve that as equal to something, you're going to use the easy form of it in part B. So you know that cosec 4 theta subtract cot 4 theta is cosec squared plus cot squared. So you can say this is instead cosec squared theta plus cot squared theta is equal to 2 subtract cot theta. And you would also like to replace the cosec squared here with cots, because everything should be in terms of cot or cot squared. Now, if you're going back to part A, you could say that cot squared is cosec squared minus 1, rearranging this equation here. You could say that cot squared is cosec squared minus 1. Or you could say that cosec squared is 1 plus cot squared. So here, instead, I will substitute 1 plus cot squared in its place. I'll combine cot squared, so I've got 2 cot squared theta plus the 1. Then I'm going to subtract 2 off both sides, and I'm going to add cot theta to both sides. And then just tidying up, 2 cot squared theta plus cot theta subtract 1 is 0. Can I factorise this? Plus 1 and subtract 1, and I can. So therefore cot theta is a half, or cot theta is negative 1. Therefore tan theta is 2, or tan theta is negative 1. So I'm going to get quite a few sets of solutions here. So let's draw out our tan graph. Our tan graph looks as so. That's 90. That's negative 90. And we're going between 90 and 180. It is to this point here. That's 180. So between 90 and 180, you will actually get no solution that is positive. So you can ignore this value here, but you will get a negative value. So this here, you do inverse tan of negative 1. When you do that, you get negative 45. So negative 45 is the answer the calculator does. But this is going to be 45 degrees back from a root. So this will be 45 degrees back from here, and it will be at 135 degrees. So therefore, the answer we're looking for is theta is equal to 135 degrees in the range we're after. And we've done for 6 marks. Okay, next question. Pause, have a go yourself. Okay, so part A, same old stuff going on here. We see this quite a lot. Sine squared theta plus cos squared theta is identical to 1. If you divide everything through by cos squared theta, you get sine squared theta over cos squared theta plus cos squared theta over cos squared theta is identical to 1 over cos squared theta. which is tan squared theta by definition plus 1 is equal to sec squared theta, and we've got our 2 easy marks. Part B says solve for theta between 0 and 360 the following equation. Give your answer to 1 decimal place. Now we can't solve this at the moment because it's got sec theta and tan squared theta, so make everything in terms of sec theta or sec squared theta. You know from part A that tan squared is sec squared minus 1, so you can substitute for tan theta as sec squared theta subtract 1 plus sec theta is equal to 1. You could expand out 2 sec squared theta subtract 2 plus sec theta, and then I'm going to subtract 1 off both sides is 0, tidying up 2 sec squared theta plus sec theta subtract 3 is 0. Can I factorise this? Well, hopefully I can. 2 sec theta, minus 1 and plus 3, I think gets us our answer, and therefore sec theta is negative 3 over 2, or sec theta is 1, so therefore cos theta is negative 2/3, or cos theta is equal to 1. So we're going to get ourselves 2 sets of solutions here. Just draw out the cos graph between 0 and 360 just to help us here. The cos graph looks like this between 0 and 360. Let's draw it a little bit back here as well. This point here is 90, it's 180, 270 and 360. If we work out theta, theta is the inverse cos of negative 2/3 for our first value from these. So keep your calculator in degrees mode, inverse cos, negative 2/3. You get yourself 131.8, so theta is 131.8. And from here, if you inverse cos of 1, you get theta is equal to 0. Now, let's pick out all our other solutions. From this one, 131.8, let's just mark it in. 131.8 is somewhere here. So we're going to get another identical solution here, which is 41.8 away from the 90. So it's going to be 41.8 back from that 270. So it's going to be equal to 228.2. So the other one's going to be 228.2 degrees. And theta is 90, theta is 0 is one solution. So here's one solution. And the other one's clearly going to be at 360. So 360 degrees is the other solution. Those two and those two are our final answer. Now, just to say finally, one tiny little mistake I made, it actually says that theta has to be less than 90, so I should have rubbed out that answer. 0, 131.8 and 228.2 are the exact answers. This one isn't one because it says theta is strictly, it can be 0 but has to be less than 360. Next question, pause the video, have a go. Okay, it says sketch on the same axis the following graphs. Show clearly the points at which the graphs meet. You're doing it between 0 and 180. So let's draw it quite big. Y equals tan x. Well, tan x looks something like this. And that asymptote there is at 90. And then from down here it asymptotes and it starts coming up towards 180. So we can rub this section out here, it's just to guide me do it. So there's between 0 and 180 what tan x looks like. And 2 cos x, well 2 cos x is like cos x but is stretched by a factor of 2 in this direction here. So it starts up here, it comes down for 90, and at 180 it would be down here at negative 2. So shown clearly all the coordinates where it meets the axis. This point here is 0, 2. This point here is 90, 0. This point here is 0, 0. And this point here is 0, is 180 even, and 0. Okay, next part. Show that tan x degrees equals 2x degrees can be written as following. So tan x, we're trying to solve tan x is 2 cos x. We want to show it can be written as following. Well, that tan x can be written as sin x over cos x. That's probably our only way to do anything here. We can multiply everything through by cos x. So sin x would be 2 cos squared x. Now we should know that cos squared x is 1 minus sine squared x. So we can substitute for cos squared x as follows. You can write sine x is 2, 1 minus sine squared x. So sine x is 2, subtract 2 sine squared x. And then we can add 2 sine squared x to both sides and subtract 2, and we get what we're looking for. 2 sine squared x plus sine x, subtract 2 is 0, and I'm done for 3 marks. And last part, hence find the values between 0 and 180 for which this is equal to that. I know solving that equation is equivalent to solving this equation here, because I've just shown it in the previous part. So I'm actually going to solve this equation between 0 and 180, and I can't actually factorise this, so I have to use the quadratic formula. Sin x, where a is 2, b is 1, and c is negative 2. So sin x is negative b plus or minus the square root of b squared, which is 1, subtract 4 times 2 times negative 2, all divided by 4, 2 times 2. So sin x is negative 1 plus or minus, this here would be square root of 17 if you work it out over 4. So if you do sin x therefore is 2 things. So sin x is negative 1 subtract root 17 divided by 4, which is negative 1.28, which you can ignore because sine has to be between 1 and minus 1, or sin x is equal to negative 1 plus root 17 divided by 4, in which case sin x would be 0.78077. So x would be the inverse sine of this. Keeping your calculator in degrees mode, and you would get that x is equal to 51.3 degrees. And what other values would there be between 0 and 180? We'll draw out your graph. You know that sin x looks like this between 0 and 180, that being 0, that being 180. If you know there is a solution at 51 degrees, there will be a solution 51 degrees back from 180. So the other one must be 180 subtract 51.3, which is 128.7 degrees. And they are our 2 answers. For this one here, we want to prove the following. Well, I would always, when I see a sec squared and say a cosec squared, I might use the identities that I know, namely that 1 plus tan squared x is sec squared x. I should know that one, and that's acceptable to just use. And I also know that cot squared x plus 1 is equal to cosec squared x. So I can use these 2 identities here, and I could just say, therefore, substituting in, I could say that 1 plus tan squared x subtract cot squared x plus 1 for the left hand side, which is simply tan squared x subtract cot squared x, which is equal to the right hand side, and I'm finished. I've got those 3 marks quite easily. Next part, given that y is arc cos x for x between -1 and 1 and y between 0 and pi, express arc sin x in terms of y. Is arc cos x, which is cos effectively to the -1 of x, then certainly cos y must be equal to x. And therefore, if I take inverse sine of both sides, inverse sine of cos y must be inverse sine of x. And that's what I was looking for, arc sine in terms of y, i.e. this side here is arc sine of x must be equal to arc sine of cos y. Quite simple question. And hence evaluate arc cos x plus arc sine x. Well, from the previous part, arc sine, we've got arc cos x and arc sine x. Arc cos x is y. Arc sine x is arc sine cos y. Plus arc sine cos y. Now you could, in order to simplify this, you could say that this is arc sine. Now cos y is the same as sine of pi by 2 subtract y. And that's because the cos graph is like the sine graph except a shift by pi by 2. So arc sine of this must be inverse sine and sine is 1. So this would be y plus pi by 2 subtract y, and this would therefore be pi by 2 because the y's would cancel and we'd be done. Okay, next question, pause the video, have a go. Okay, working through this, we can't solve any of these until they're all in terms of cot squareds, for example. So we should know the identity that cot squared theta plus 1 is equal to cosec squared theta. So we can replace cosec squared 2x, for example, by cot squared 2x plus 1 minus cot of 2x is equal to 1. And then we could say that cot squared 2x plus 1 subtract cot of 2x and then subtract 1 from both sides is 0. So cot squared of 2x subtract cot of 2x is equal to 0. That 1 and that negative 1 cancel. So we could factorise cot 2x and we could say that out, because there's a cot 2x in both, we'd have cot 2x subtract 1 is 0. So on the one hand, cot 2x must be 0, and on the other hand, cot 2x must be 1. So where is that? That tells us that tan 2x, well, would be 1 over 0, which is infinite. So this is telling us where tan 2x is tending to infinity and where tan 2x is equal to 1. They're the solutions we're looking for. So let's draw ourselves our graph. Because we're dealing with 2x, we're going to double our range, our domain 0 to 180. So I'm going to draw the graph between 0 and 360. 270, 360. So we're getting various solutions. Where is the tan graph approaching infinity? Well, it's approaching infinity at 90 and at 270. So therefore, from here, 2x is 90 or 270. And where is tan 2x equal to 1? Well, 2x would therefore be the inverse tan of 1, which is 45. So there'll be a solution at 45 here, and there'll be another solution at 100 and 225 here. So there's a solution at 45 and 225. Dividing it all by 2 and putting them in order, I would therefore have 45 divided by 2 is 22.5 is my smallest value. Then I would have 90 divided by 2, which is 45 degrees. Then I would have 225 divided by 2, which is 112.5 degrees. And then I would have 270 divided by 2, which is 135 degrees. And they are all my 4 solutions to this problem, and I've totally finished now. And that's everything that's come up on the past paper questions on simple trig equations using the simple identities. Thank you very much for watching. I hope you found it useful in your revision.